Here, this is your flame sensor. It performs flame rectification. That's turning a AC voltage into a DC voltage and sending a DC microamp signal to the board, letting the control board know that there's a flame ignited on the board. Right. This is your combination gas valve. And of course, it releases the gas through the manifold, through the orifice into the in-shot burners. So that's what this is. It operates on a 24 volts. This is your induction motor. It creates a negative draft in the heat exchanger and a positive draft in the flue. All right. What this does is this is one of the elements you need for fire. You need fuel, oxygen, and heat. This induction motor brings the oxygen into the equation, all right? It pulls in the air through the heat exchanger out the flue. The second element, well, this is actually not the proper sequence, but the second element you need is heat. Your HSI provides the heat, and it heats up to 1800 to 2000 degrees. And so the gas valve provides the fuel. When it opens up, it sends the fuel into it, and that hits the HSI and ignites. All right, so this creates the negative draft in the flue, positive draft, negative draft in the heat exchanger, positive draft out the flue. The pressure differential switch reads or picks up on the negative draft, and it closes the switch, and it sends a 24 volt signal back to the control board to let the control board know that there's adequate ventilation to go on with the sequence. All right. And of course, your blower assembly and your blower motor is down here. That's the last motor to turn on, and it's the last motor to turn off. So on your stand and delivered, the question will be, thermostat calls for heating. What happens next? Your job is to tell me that 24 volts is sent through the W circuit to the control board. The control board then sends 120 volts to the combustion motor. The combustion motor energizes, creates a negative draft in the heat exchanger, positive draft in the flue. The pressure differential switch reads the negative draft, closes the switch, sends 24 volt signal back to the control board to let the board know that there's adequate ventilation. The next thing the board will do is will send 120 volts to your hot surface igniter. It will heat up to 1800 to 2000 degrees. After a short delay, the board will send 24 volts to your combination gas valve, which will release the gas through the manifold, through the orifices into the in-shot burner, hits the HSI, ignites, spreads by the spreaders, then it surrounds the flame sensor. Once it surrounds the flame sensor, flame rectification is completed. It sends a DC microamp signal back to the board, letting the board know that you have fire. So everything's going good up here. After a short delay, allowing the heat exchanger to heat up, the board will send 120 volts to your blower motor. Indoor blower motor will start up, send the heat through the conditioned space, cool off the heat exchanger at the same time. Satisfies the thermostat. Thermostat discontinues the 24 volts to the board. The board then discontinues the 24 volts to the gas valve, which puts out the fire. All right. Now that the fire's out, the induction motor will continue to run for a few seconds to pull out all the exhaust, the exhaust from combustion, sends it out the flue. After a short period, it turns off. The indoor blower motor will run for a few seconds to cool off the heat exchanger. After a few seconds, it will turn off, and the system will wait for the next call for heating. That's your furnace sequence of operation. All right?
Excuse me. He did it. The teacher.
All right. Well,